Okay, so to recap, here's what we're doing. We have a function here, right? Some function. In order to be able to evaluate that function at a specific point, we are going to use this tangent line as a way to evaluate it, because look at the point, they're so close, right? I want you guys to be able to see this. At that point, their y values are so close that I could evaluate, y equals mx plus b at a point like 1.4, but not the ln function, right? So that's why I use the tangent line as a way to evaluate. All right, and everybody's okay with how we got this? Yes? Y minus y1, huh? Yeah? Y minus y1 equals mx minus x1. All right, so let's talk about specifics then. For this to work, f has to be differentiable at x equals a. Then we can use the equation of the tangent line, right? And what is the equation of the tangent line? It's y equals y1 plus mx minus x1, right? F prime of it is mx minus x1. And because we're using this as an approximation for the function value, as a linear approximation, we call it L of x. This is a linear approximation, all right? So the approximation f of x is approximately equal to L of x, okay, is what we call the linear approximation of f at a, okay? X equals a is the center of the approximation, so that's where we're like zooming in. All right, let's put that one to use, okay? We want to find for each of these problems, so here we're given an f of x in part 1 and an a value, -4. We want to find the linearization or the tangent line of f of x at x equals a. So part A is asking you to come up with that L of x equation, all right? Then part B says use that to approximate f of a plus 0.1, all right? How accurate is the approximation to the actual value? Okay, so first for part A, I want to come up with that L of x equation. Well, what does the L of x equation call for? It calls for f of a, f prime of a, and so on. A is -4. Okay, so first let's find f prime of x. All right, so again, I want you guys to be quick when we're working with roots, right? Remember what I said before, right? Let's get used to the fact that when you have the square root of something, the derivative is just 1 over 2 times the square root. And of course, we have to use chain rule times 2x, okay? The 2's cancel, so f prime of x is x over the square root x squared plus 9. Okay, now, okay, so the L of x calls for f prime of a, right? F prime of -4 is -4 over the square root of 25. So basically it's -4 over 5. L of x also calls for f of a, which is f of 4, -4. So that's the square root of 25 is just 5. Okay.
Oh, just a on the bottom.
Right. So L of x is, look, it's f of a, which we said was 5, plus the slope, which is -4 over 5, x minus a, x plus 4. Okay, this is the linearization. Matthew, can I ask you to sit properly?
Sure.
Thank you. So this is the linearization. In other words, this is the equation of the tangent line, which we're going to use to evaluate our function. Now, because this is an approximation, right, we also tend to use that approximation symbol. Okay, Next, so that was part A. Part B says, now use this to estimate f of a plus 0.1. So I want to estimate f of a plus 0.1, so it's negative 4 plus 0.1. Okay, so f of negative 3.9. All right, now let me ask you this. Are you able to plug negative 3.9 into f of x mentally and get a value? No, but look, you can get a very close value using this L of x. Okay, so here's what we're going to do. L of negative 3.9 is approximately 5 minus 4 over 5, negative 3.9 plus 4. What's negative 3.9 plus 4? It's positive 0.1, which is 1/10. 1/10, right? So let me show you guys something. L is approximately equal to this. But now, if I want to do the arithmetic on the right side of this, right, I'm going to say that is equal to 5 minus 4 over 5 times 1/10. Okay? Which is 5 minus 2 over 25. Okay? All right. So let's simplify that. So what would that be? Okay, so what's 5 made of? 5 is made up of a 4 and a 1, correct? Yes? Yeah. And can you say that 5 is actually 4 and 25 over 25? So this is really 4, 23 out of 25. Okay? So that is the approximation. So look at what you did. You actually evaluated this f of x at 3.9, right? You would never have been able to do that before, or at negative 3.9. You would never have been able to do that before without this. Now, while I take questions, please take out your calculators. I want you guys to approximate that using your calculator. Okay, so let's check how close these are. So this is approximately 4.92, right? And then how much would f of negative 3.9 have been? So basically negative 3.9 squared in the square root plus 9. How much? Well, I'll tell you, I have it here apparently. It's 4.9203. Oh my God, look at how close we got to the actual value.
Oh my goodness. Oh yeah, all in
Mental math, right? Okay. So, all right, so let's do another one. Look at this one. ln of x plus 1. Right, let's write the linearization. F prime of x is how much for this?
So those are two ways, right? Well, we just did it with two separate ways. One was just plugging in 3.9. It's the LN, the other one was.
Right, but I only did this blue to show you guys how close we got. This is not finding it, this is just evaluating. That's not linearization. The purple is the linearization. Yeah. Okay, so what's f prime here of ln of x plus 1?
1 over x plus 1.
Yes. Okay? All right, so for this linearization, I need f prime of 0, f prime of a, and f of a, f of 0. F prime of 0 is 1 over 1, which is 1. F of 0 is ln of 0 plus 1, which is how much these days? How much?
0.
0, good. Just checking. So y equals f of 0 plus the slope times x minus a, which is 0. Well, look at that. Y equals x, right? So, why is that y? It was supposed to be L of x. Oh my, Miss Malikian. L of x is approximately x. Okay? L of x is approximately x. Okay, so that's the linearization. Now, what we're asked for in part B is to find L of a plus 0.1. Okay? Oh, look at how easy that is, right? You just plug 0.1 into L of x, which is just 0.1. And now let me ask you this. Did you ever in your mind, like, did you ever even think that you would be able to evaluate ln of, okay, 0.1 plus 1, right? Never, okay? All right. Isn't that cool?
That is.
You're not as excited about this as you should be.
That's so rad.
I know.
Don't take it personal. Yeah, let's
All right.
Come on.
Well, maybe this will
No, it is.
make you guys appreciate. All right, so look, root 80. We're going to approximate root 80 using this linearization method, okay? All right, so if I'm going to evaluate root 80, that is like if I had a function f of x, so let's say let f of x equal to root x. It's like I have a function f of x equals root x. Let's imagine how that looks. F of x equals root x. And now I'm evaluating it at x equals 80, right? That's pretty much what this is, right? So we want f of x to be x. But how about a? Now we need to pick an appropriate value for a that makes our life easy a little bit. So what we're going to do is we're going to approximate at an appropriate nearby number. So if you're dealing with root 80, right, if you're dealing with a square root, what's a very close number to this that you could work? 81, right? So we're going to use a equals 81. All right, so if f of x is root x, what's f prime of x? You guys know, come on.
1 over 2 root x.
1 over 2 root x. So f prime of a is f prime at 81, 1 over 2 times 9, 1 over 18. Do you see why we used 81? Okay. Because you want something in here that is like easily evaluated.
So
Now,
did you purposely pick 81 because you knew it would eventually be?
Right. So remember,
square-rooted?
so look how it says pick an appropriate number
Right,
nearby.
so you wouldn't pick 79. Because
Right.
You would eventually
Right.
be.
Exactly. You want to pick like the very closest like root or perfect square.
So what if it was like, what if the number they gave us was like a 70?
Well, what's the closest one? 64. Then you would do
Right, no,
64.
like a
Right.
6 number gap.
You have to be close. It would have to be something that you're close to.
Even so 70 is still 64 is still the closest 7.
Right.
Yeah, I was going to ask, how do you like judge its appropriate?
So in order for it to, well, you just go to the closest possible one, right? And you're not going to be given something that is way off anyway. Like you're going to be given something that's very, very close by.
72.5.
All right.
In the middle.
So, okay, so what's L of x then? L of x is approximately, so the y value, which is 9, plus the slope, x minus x1. Okay? So L of x, I'm sorry, we want L of 80 now. L of 80 is approximately 9 plus 1 over 18, 80 minus 81. Okay? So this is equal to 9 plus 1 over 18 times negative 1. So this is 9 minus 1 over 18. Which if we split 9 into 8 and 17, 8 and 18 over 18, this is 8, 17 over 18. All right, and look at that. You just approximated root 80. Okay, so it just so happens that this is approximately equal to 9.44 repeating. And root 80 is 9.4, I'm sorry, hang on. It's 8 point, sorry, I wrote that wrong. It's 8.944. And this is 8.9, tell me, 427. Okay, look at that. Like it's dead accurate, right? Up to 3 Decimal places, the AP sanctioned 3 decimal places. All right?
Oh, and then that's just the original.
I know. All right, so let's do cube root of 26. Same situation, right?
The mixed numbers of the improper fraction is your actual answer.
Right.
You don't need to even write it down.
Correct. So cube root of 26, right? What are we going to let y equal or f of x equal? Cube root of x. So f prime of x, right, is 1/3 x to the negative 2/3. So this is equal to 1/3x to the 2/3, right? Okay. What are we gonna take as our a?
25.
27, because that's a good cube root. This is a cube root. So f prime of 27, I know, did you see what I did there? Is 3 times.
I always want something that's an easy number, so that way you don't have to deal with it.
Precisely. So now look, it's the cube root of 27 squared, and this is something you should be able to do by hand, right? Well, let's see what that is. That's 1/3 times cube root of, what's 27 in terms of 3? 3 cubed squared, okay? So that's 3 to the 6, right? How does it come out of the cube root? 3 to the second. So it's 1/9, 27. Okay? Now we need f of 27, which is cube root of 27, which is 3. All right, so tell me, what does the linearization look like? Uh-huh.
3 plus
127 times x minus 27.
Fabulous. Okay? So now, L of 26 is 3 plus 1/27, 26 minus 27. This is 3 minus 1/27, which is how much? Right. Okay?
That's pretty quick.
Okay, so, all right, here we go. This is how, this is one way that we are usually asked this question. So look at what we're given here. We're given f of 2 is -6, and we're given f prime of 2 is equal to 3. So that tells us that this number 2 is our a. All right? We want to use a tangent line to approximate to f of 2.1. So first I want my L of x approximation, and that's going to be, tell me, right? It's f of a plus f prime of a. So tell me, what do I put down here? Huh? -6?
Plus 3 times x minus 2.
Precisely. Okay? Now, I'm going to use that to approximate f of 2.1.
You plug in and L of 2.1.
Yep. -6 plus 3 times either. So f of 2.1 is approximately this.
Yeah, I would have thought L.
Well, okay, so remember what we said here is, there actually is f of x is approximately equal to L of x.
Okay,
So
so
when
it's the
it's
same
the
thing.
approximation, it's approximately the same thing.
Okay.
So now this is equal to -6 plus 3 times 0.1. 0.3.
I just haven't got
Was that a joke? Was that a joke?
I haven't thought that simply in so long.
-6 plus 0.3 is
Something.
how much?
5.7.
Huh?
-5.7.
-5.7. All right.